Hi, Chris Guzmal here. We are going to be studying today related rate problems. In related rate problems, we vary something, a volume, an area, a distance, an angle, and that varies in terms of, these things can typically vary in terms of one another, and that relationship dictates the relatedness of the related rate problem. So for example, your volume might be 4/3 pi r cubed. And if we ever give a function that describes R, we can infer the volume. I mean, it's like it's going to be through that scary function formula relation that relation. Um, and that's what you've typically done in the past in algebra. Now in calculus, what we'll do is use the same relation, but now we say that what happens when the rate of change of something is going on, and we'll have to use taking the process of taking the derivative in order to solve the problem. But it's nothing other than throwing in taking the derivative once we set up the relationship appropriately between objects. So here's a word problem and where there's a relationship. A car travels at 1 foot per second on wheels that have 20-inch radii. Okay. The wheel rolls over a tiny piece of gum that sticks to the tire. This is just, we're just trying to visualize something where something starting at the bottom of the wheel and then rotates up a certain distance. After 1 second, how fast is the gum moving up is the question. Also, what is the angular velocity of the tire at that time? And so our altitude is going to be 12 times the sine of the angle that we get from 1 foot. We're 12. Remember that 12 is the radius. Where did I get that? Let's take a look at this. This is just showing us the wheel, and it's rotated a certain distance, and the question is how far above the ground the piece of gum is. And this GeoGebra illustration makes it a little bit more clear, I hope. We have see if yes, we have at point C down here the point of contact of the wheel to the ground. After 1 second, that point of contact is moved up to point D as a function of the speed. This red red arc, which is marked with the lowercase d, indicates the distance that we've traveled after 1 second, which is going to be 12 inches. 1 foot per second, 12 inches, right? And so the question is, what's this height? And the height is just going to come from trigonometry. That is going to be the radius times the sine of d. If we view d as the angle as opposed to the actual distance along radius. So this is a little deceptive because the radius is here already set. So really, it should be r sine theta, where theta is the angle of the arc from C to D. But the relationship is basically the sine of the angle. Okay, and so we just want to find the angle. All right. The angle from traveling 1 foot is based on the fact that the radius is 20 inches. I said 12 inches earlier, so radius is 20 inches. So the circumference is 40 pi inches. That's 2 pi times that. Moving 1 foot is 12 inches. So 12 inches of the way around the circle is 12 divided by 40 pi of the way around the wheel. And so one rotation around the wheel is 2 pi radians. And so 2 pi times 12 times 40 pi. Oh, that's meant to be 12 over 40 pi, but I did that right there. And the next, I divided by 40. And so the pi's cancel, and the final answer is 0.6 radians per second, which is our angular velocity, which is part of the question. And how much height does that produce? If 0 radians has you on the ground, then 0.6 radians puts you sine of 0.6 radii above the ground. Our radius is 20 inches, so our altitude is 20 times the sine of 0.6 inches after 1 second. And the cool thing is that our upward speed is going to be the derivative of 20 times the sine of 0.6t, which is 0.6 times 20 times the cosine of 0.6t.